All right, ladies and gentlemen, so now we're going to finally get to that simulation problem that I talked about in the previous video when we were talking about representing numbers as events or outcomes. Okay, so again, we just had a raffle that was going on, 650 tickets that were student tickets, faculty was 325. The principal reaches into the jar, 3 are winning tickets, and they're all faculty. So the students are so upset, blah, blah, blah. They argued that it wasn't properly mixed, so on and so forth. So what we can do is we can use simulation to determine if the outcome of the drawing could reasonably be expected to have occurred if the tickets were properly mixed. So we're using simulation. There are some steps you do need to follow here. Step 1, state, let me hide my spoilers. What's the probability that all 3 winners will be faculty members? So this right here, step 1, the state is state the question of interest. Okay, state the question of interest. 3 tickets that were pulled out were faculty members. We cried foul on that. We want to use probability to see what are the chances of that happening, okay? What are the chances of that happening? So we restate that and we say, what's the probability that all 3 winners will be faculty members? We want to know if this is a likely event or an unlikely event, okay? Again, we want to know if this is a likely event or an unlikely event, and we're going to use simulation to predict the probability of this happening. Okay, next. Step 2 is our plan. In this step, I am looking for some things. Labels, trials, repeats, stop, and analyze. How are you going to go about and simulate pulling tickets out of a big jar? Okay. Label. We have a faculty member and we have students. I am labeling a faculty member 1 and a student 2 and 3. Why am I doing that? Going back to where we practiced representing events as numbers. What proportion of the time should that outcome happen? Well, we have 650 student tickets. Okay. We have 325 faculty tickets. Together, we have 975, which simplifies to 1/3. And again, 650 divided by 975 total tickets in that jar, that simplifies to 2/3. And that's why I chose the numbers 1, 2, and 3 to represent 1 as a faculty member. 1 is 1/3 of my 3 numbers, and 2 and 3 will represent students, 2/3 of the 3 numbers. Now what we want to do is we want to simulate if we had a big jar with those 975 tickets, we want to simulate pulling out tickets. Okay, so what I'm going to do is I'm now going to teach you how to use the calculator to generate random numbers. For each trial, we will simulate drawing tickets using a calculator. We could use a random number table as well, but I want to show you the calculator. I've already taught you how to use the random number table. We're going to draw 3 tickets. So we're going to simulate 3 tickets by randomly generating 3 numbers from 1 to 3. Okay. We will record it as a 1, 2, or 3. Here's our label part. A 1 equals a faculty member. A 2 or a 3 equals students. Now, do I have to show this up here? No. I can just start right here talking about the trial, right? How I'm labeling it. It does not need to be in this order. We can accept repeats during simulation. The majority of the time you accept repeats, okay? We can accept repeats and we will stop the trial after we have generated 3 numbers, okay? We will continue this for 10 trials or several trials. Remember, probability is long range. It's after several repetitions. We will then answer our question. We want to know, what's the probability? Is it likely to pull out 3 faculty members or not likely to pull out three faculty members? So we're going to analyze the proportion of trials that were all faculty members. Again, I'm generating this whole idea of taking tickets out of a big jar. That jar has 1/3 of those tickets. 1/3 of those tickets are faculty members and 2/3 of them are students. Okay, so let's pull up our calculator. Okay, so we should have our calculator open now. And what we want to do is we want to hit math. We want to arrow over to PRB or PROB, like my calculator here. We want to generate random integers. So I'm going to go to number 5. That's for mine. Now you may have an old calculator. I'll talk about what you need to do if you have an old calculator. But what I want to do is I want to talk about my lower bound to my upper bound. So my minimum number of the numbers I'm going to generate and my maximum number. So that's 1. And then I have 3. And then how many numbers do I want to generate? I want to generate 3 tickets, and repeats don't matter. So I can generate 3 tickets. And then I'm going to hit enter at paste. Now, those of you with the old calculator, when you hit rand int, you'll see the parentheses here, and then you're going to type 1, comma, which is right here under the sign, 3, so this is my lower bound, this is my upper bound, or my minimum number of the numbers I've generated, and my maximum number of the numbers that I'm representing for those events, okay? And then I'm going to generate 3 tickets. So I'm going to hit enter. So here's my first trial. So my first trial, when I pulled out tickets, right, I got a student, and a faculty. So now what I want to do, you guys, is we need to now actually analyze, record and analyze what's happening. So my first trial, trial number 1, I got 331, I think it was. Let's see. 331, which means I had student, faculty. Was it the prescribed condition? Well, what does that mean? That is the question we're trying to ask. Is it going to be all 3 faculty members? And this was no. It was not all 3 faculty members. So I want to do this again. I want to do another trial. Oh, sorry, guys. If I just hit now enter, or no, whoops, I'm not on my calculator, sorry. It will do it again for me, okay? I just have to hit enter. I don't need to retype it every single time. 2, 2, 3, okay? So that was actually 2, 2, 3, right? If we look up here, 2, 2, 3, well, that's all 3 students, okay? So student, was that the prescribed condition that we're looking for? No, that wasn't, okay? We're looking to see if we have all 3 being faculty members. We're going to do it again. Might as well just do this because it's not working very well. I'm going to be on my calculator and I'm going to hit enter. Now I have 1, 2, 3. Oops. 1, 2, 3 would be a faculty student. That is not my prescribed condition. 4, let's do it again. Let's see, I accidentally hit 2 there, so I don't know if it's going to work for me. Oh, it did. 1, 3, 3. Again, that's going to be faculty, student. We're going to keep this up. So I want you to practice in your calculator. I'm not going to make you go watch all 10 trials, but I'm going to pause right now. I'm going to do the 10 trials. I want you to practice the 10 trials as well. And if you want to see one more time just how to get that random in, here's how you get it. We hit math. We arrow over to PRB or PROB. We go to random integer. For me, that is number 5. I have my minimum number of the numbers I'm representing and my maximum number. So 1, 2, and 3 I'm representing. So I put a 1 and then a 3. N means I'm pulling out 3 tickets, okay? And then I'm going to hit paste, enter. Again, if you have the old calculator, when you hit rand int, you'll just see rand int with this parenthesis here. You hit 1, comma, 3, comma. So because I'm generating numbers 1 through 3, and then I'm generating 3 tickets. And I hit enter. So I have 1, 2, 1 there for my 5th one. So I'm going to pause it right now and I'm going to do my 10 trials. You go ahead and do the same thing. Okay, so what you can see here is I just generated my simulation, right? I did 10 trials. So should we have more trials? Yeah. So, I don't know that 10 is really the biggest sample size, but I also don't want you to be like wasting away your night generating random numbers for a simulation. So what we did is We did this simulation over and over again. We did it 10 times. We asked ourselves, did we get our prescribed condition? Only got my prescribed condition once. Okay. So, oops. I don't know why I put a yes there. No. Okay. I only got my prescribed condition all faculty once. So what does that mean? So how do we answer what does this mean? We need to analyze this right now. Okay. And when we analyze this, we need to do a little bit of math. So we need to say, well, out of our 10 times, how many times did we get our prescribed condition? And that was only once. So 1 out of 10, that's 10% of the time we got that prescribed condition. Now we have to say, is that a likely event or not a likely event? Now, if I told you the chances are going to rain tomorrow is 10%, would you say it's likely it's going to rain or unlikely? Lots of you are going to say unlikely, but actually in statistics, we only say that something is unlikely if the probability of it happening typically, now not always, but typically our standard rule of thumb in statistics is something is unlikely if the probability of it happening is at 5% or lower than this. So although this is not terribly likely, it is not an unlikely event, okay? It is not an unlikely event. Okay, so how are we going to conclude that? That's step 4 now. That's step 4. Was the bowl properly mixed? This is not an unlikely event, which means it's likely it could have happened. So should the students have cried foul? Not necessarily, because there is a 10% chance it could have happened, and that's not terribly unlikely. How are we going to sum that up in a nice, concise statistical statement? Let's do that now for our last step.